Good morning, my dear students. Today we are going to discuss about binomial theorem. Okay, students, the properties of the binomial coefficients. Okay, students, so the sums are related to the properties of the binomial coefficients only. Okay, now students, the C1 by 0, 2 into C2 by C1, 3 into C3 by C2, and so on. N into Cn minus 1 is there. Simply, dear students, we can written as 1 is there, R equal to 1 to N. That is what, students? R into Cr by Cr minus 1. Is it clear, student? R into, what is the, students? R into Cr minus 1. So, students, when we are taking R equal to 1, C1, 0. When we are taking R equal to 2 into C2 by C1. R equal to 3, that is 3 into C3 by C2. Is it clear, students? Now, students, how can you write this is sigma R equal to 1 to N R. CR is nothing but NCR. CR is the, students, NCR. CR minus 1 is the, students, NCR minus 1. So, students, sigma R equal to 1 to N R. This is, we can written as the, students, suffix R is there, R minus 1 is there. Undoubtedly, we can written as the, students, R. This is the, students, N minus R plus 1. How to write the, student? This is N minus R plus 1. Suffix is the bigger. This is R. So, we know that NCR by NCR minus 1 is the N minus R plus 1 by R. So, students, these are cancelled. Now, students, we are substituting first R equal to 1. That is 1 cancel. That is N. After that, students, when we are taking R equal to 2, that is the, students, N minus 1. Okay, students, and so on. When we are taking substitute N, undoubtedly that is 1. Dear student, when we are taking N minus 1, and when N before is the N minus 1, N cancel, minus of minus plus 1, that is 2. So, students, 1 plus 2 plus and so on N. The last term is there N. What is the, students? 1 plus 2 plus 3 plus and so on N. This can be also, we can written as 1 plus 2 plus 3 and so on N. This is the, student, sum of the first natural numbers. The sum of the first natural numbers is N into N plus 1 by 2. What is the, students? N into N plus 1 by 2. Okay, students, write down N into N plus 1 by 2. Okay. Now, my dear students, is there 3 square, 3 power N. So, students, it is very simple, students. Quite simple. 1 plus x whole power N is C0, C1x, C2x square, C3x cube, and so on Cn x power N. What is the, students? C0, C1x, C2x square, C3x cube, and so on Cn x power N. So, students, now here we are substituting simple, student, it is when it is there 4, undoubtedly we can the standard binomial expansion. Okay, students, in the standard binomial expansion we are taking x equal to 3, then it will be 4 power n. Suppose 5 power n is there, we are taking x equal to 4. So, student, that is, now we are taking x equal to 4. This one, my dear students, 1 plus 4 is the 5 power n. 1 plus 4 is the 5 power n. So, student, this can be written as C0. After then, what is the, student? 4 power n is there. 4 power n is there. Undoubtedly, we are substituting x equal to 3. 1 plus 3 is the 4 power n. After then, C0. This is 3C1. Now, student, 3 square into C2. After then, students, 3 cube into C3. So, students, 3 power n into Cn. 3 power n into Cn. Is it clear, students? Now students, this is 4 power n C0, 3C1, 3 square into C2, 3 cube into C3 and so on 3 power n into Cn. Is it clear students? Dear students, this is very important students. C0, C1x by 2, C2x square by 3, Cn x power n upon n plus 1 equal to students 1 plus x whole power n plus 1 minus 1 upon n plus 1 into x. Dear students, suppose into x is sending to other side, this is x square by 2, x cube by 3, x power n plus 1 upon n plus 1. So, dear students, how can you write this is? This is the very important students. We know that, dear students, we know that C0, C1x, C2x square, after then Cn x power n is the formula of standard binomial expansion. What is the students? 1 plus x whole power n. 1 plus x whole power n is the C0, C1x, C2x square and so on Cn x power n, that is 1 plus x whole power n. So my dear students, right now we are taking the integrals 0 to 1 integral. We can apply on both sides different integral having the limits 0 to 1. This is what students? C0, C1x, C2x square and so on Cn x power n. When the denominators are there 2, 3 like this, undoubtedly we are taking the integration. Okay students, after that this is also 0 to 1, 1 plus x whole power n dx. My dear students, here we can observe C0, 1 dx is the x, after that C1 x square by 2, after that students C2 x cube by 3, Cn x power n plus 1 upon n plus 1, limits are 0 to 1. Okay students, now this is the integral of 1 plus x whole power n is the 1 plus x whole power n plus 1 upon n plus 1. The limits are 0 to 1. So students, right now we are substituting the 1. My dear students, when we are substituting, dear students, my dear student, first of all, we are taking the limits 0 to x. After that we are taking, my dear student, 1. The first in terms of x is there. So dear student, after that we are taking the x equal to 1. Okay students, this is my dear students, we are taking the limits 0 to x only. So first of all, everybody substituting replaced by x is the x. This is what students? C0x, C1 x square by 2. After then C2 x cube by 3. This is what students? Cn x power n plus 1 upon n plus 1. Minus substituting x is 0. That is 0 square 0, 0, 0, 0. So dear students, now substituting, this is 1 plus x whole power n plus 1, dear students, upon n plus 1 minus, when we are taking x equal to 0, this is what students? When we are taking x equal to 0, 0, 1 power n plus 1 is the 1 upon n plus 1. My dear students, we observed each and every term is including x in the left hand side. So students, divided by x on both sides. This is C0. After that C1x by 2. This is C2x square by 3. And so on. Cn x power n plus 1. Okay students, this is 1 plus x whole power n plus 1 minus 1 LCM is the n plus 1 into x. Is it clear, students? We are taking the LCM is the n plus 1 and also we are divided by x on both sides. This is C0, C1x by 2, C2x square by 3, Cn x power n by n plus 1. That is what? 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. This is the one of the students very important theorem. Now students, suppose we are taking x equal to 1. So dear students, when we are substituting x equal to 1, after completion of the theorem, put x equal to 1, this is C0, C1 by 2, then C2 by 3, and so on is there, Cn upon n plus 1. That will be, students, 1 plus 1 is the 2, 2 power n plus 1. What is, students? 2 power n plus 1 minus 1 upon n plus 1. Okay, students, 2 power n plus 1 minus 1 upon n plus 1. Okay, students, this is the very important. Suppose, students, when we are taking x equal to 2, this is C0, C1 into 2 by 2, C2 2 square by 3, and so on, Cn 2 power n by n plus 1. This is 1 plus 2 is the 3, 3 power n plus 1 minus 1 upon n plus 1 into 2. So the 2 is also sending to the other side. So dear students, we observed 3 power n plus 1, that means we are substituting x equal to 2. Suppose is there 4 power n plus 1 is there, undoubtedly we are substituting x equal to 3. Suppose 5 power n plus 1 is there, on both sides we are taking x equal to 4. 1 plus 4 is the 5 power n plus 1 minus 1 by n plus 1 into. Okay, students, write down. My dear students, C0, C1, C2 and so on, Cn are the coefficients of in the expansion 1 plus x whole power n. Then C0 Cr, C1 Cr plus 1, C2 Cr plus 2 and so on, Cn minus R, Cn, that equal to 2n factorial by n minus r factorial into n plus r factorial. Okay, students, my dear students, here how can you write this is? Just now, students, we have to know that the expansion of 1 plus x whole power n is C0, C1x, C2x square, and so on, directly Cr x power r, Cn x power n. Okay, students, now another one is the students x plus 1 whole power n, C0 x power n. C0 nothing but NC0, n minus 0 is the x power n. After that, students, C1 x power n minus 1, C2 x power n minus 2, and so on, students, Cr x power n minus r, and so on, students, Cn, n minus n is the x power 0, that is 1. My dear students, is there C0 Cr? That means, suppose this is C0, is there Cr? So, my dear students, now we are equating the x power n plus r coefficients. This is 1, this is 2. So, the right hand side, the first we can write 1 into 2 implies the coefficient of x power n plus r in the RHS side of the 1 into 2. My dear student, what is there? C0 into Cr. Yes. Suppose, students, when we are taking this is the C1, undoubtedly, my dear students, when it is r plus 1, Cr plus 1, x power r plus 1. Undoubtedly, student, plus 1 minus 1 are cancelled. that is also x power n plus r. So C1 Cr plus 1. Similarly students, C2 Cr plus 2. When we observe the students, what we observe the students, then you can write, my dear students, undoubtedly we can written as the Cn minus r Cn. What is the students? Cn minus r Cn. Is it clear students? So this is the right hand side. My dear students, the Cn means x power n. This is what students? Cn minus r means x power r. Cn is the x power n. Now after multiplication we got undoubtedly x power n plus r. So students, right now we have to find the coefficient of x power n plus r in the left hand side of 1 into 2. That implies, what is the student? 1 plus x. This is also 1 plus x. That means 1 plus x into 1 plus x is the students 1 plus x whole power 2n. What is the students? 1 plus x whole power 2n. What this means is the students, the coefficient of x power n plus r is here C0, C1x, C2x square, C3x cube. Similarly, Cn plus r is the students, Cn plus r is the x power n plus r, where Cn plus r is nothing but, what is the n? Indeed, index is 2nc. What is the students? 1 plus x whole power n is there. Undoubtedly nc we can written as Cn plus r means here n is there. But here we are taking 1 plus x whole power 2n, Cn plus r, x power n plus r. The coefficient is undoubtedly the 2nc n plus r, since where n is the 2n. So students, the 2nc n plus r. So now equating C0 Cr, C1 Cr plus 1, C2 Cr plus 2, and so on. Cn minus r Cn, that is the students 2nc n plus r. What is the student? 2nc n plus r. Dear students, how can you write this? Is the 2n factorial. What is the students? 2n factorial upon 2n minus n minus r factorial. After that students, n plus r factorial. What is the students? The 2nc n plus r is the 2n factorial by 2n minus n minus r factorial into n plus r factorial. Okay students? So dear students, now we prove that C0 Cr, C1 Cr plus 1, C2 Cr plus 2, and so on. Cn minus r Cn is the 2n factorial by n minus r factorial into n plus r factorial. This is what students? This is 2nc n plus r. 2nc, 2n minus n minus r. We know that nc r is the form nc n minus r. So students, 2nc n plus r also can be written as 2nc 2n minus n minus r. So students, now we can written as, my dear students, this is also we can written as 2nc n plus r. So dear students, right now we are taking r equal to 0. My dear students, with r equal to 0, substituting r equal to 0, that is C0 into C0, C0 square. After that students, r equal to 0, this is C1 square. After that students, C2 square. After that Cn square. This is the 2n Cn. Very important students. This is a very important formula. How can you write C0 square, C1 square, C2 square, and so on Cn square is the 2n Cn. What is the student? 2n Cn. 2n Cn. 2n Cn is the formula. Okay, students. Now, students, substituting r equal to 1. What is the students? When we are substituting r equal to 1, that is the student C0, C1, C1, C2. After then C2, C3, and so on C. What is the student? C, R is the 1, n minus 1, Cn. Then it is the students 2nc. Okay, students, n plus 1. What is the students? When we are taking r equal to 1, this is C0, C1, and the students C1, C2. And C2, C3, Cn minus 1, Cn. Finally, you can take 2nc n plus 1. Okay, student, this is C0, C1, C1, C2, C2, C3. Value is the students. Undoubtedly, how can you write the students? This is 2nc n plus 1. 2nc n plus 1. Okay, students. This is also, students, we can written as 2n factorial upon n minus r factorial, 2n minus n minus 1 factorial into n plus 1 factorial. Is it clear, students? 2n factorial by 2n minus n is the n minus 1 factorial into n plus 1 factorial. Okay, students? My dear students, 3 into cg square, 7 into c1 square, 11 into c2 square, and 4n plus 3 into cn square equal to, dear students, 2n plus 3, 2n cn. My dear students, here 3, 7, 11, these are all in undoubtedly AP. What is the student? These are all in AP. Okay, students? My dear students, so here, how can you write? This is the students. Just 1 minute, students. The S will be taken as 3 into C0 square, 7 into C1 square. My dear students, 11 into C2 square, and so on. 4n plus 3 into Cn square. My dear students, now we can write the S. You can write the last term at the beginning. This is 4n plus 3 into Cn square. The before term is 3 plus 4, 3 plus 4, 7, 7 plus 4, 11. So students, 4n minus 3 minus 4, that is the students 4n minus 1, that is n minus 1 whole square. After that, student, 4n minus 5, n minus 2 whole square. This is the students 3c0 square. So dear students, this will be taken as 1. How to write the student? This is 4n plus 3. Cn means NCN. Cn means NCN. Therefore, n minus n is the 0. This is the students 4n minus 1. N minus of n plus 1. N cancel. This is C1 square. After that, students 4n minus 5. This is C2 square. And so on 3. NC0 is the n minus 0 is the n. Cn square. This will be taken as a 2. This will be taken as 2. Now students, how can you write? This is 1 plus 2. That implies S plus S is the 2S. Dear students, 4n plus 3 plus 3. That is the 4n plus 6. C0 square. After that, student, this is minus 7 plus 1, minus 1 plus 7. This is also 4n plus 6 into C1 square. This is also, students, 4n plus 6 C2 square. My dear student, this is also 4n plus 6 into cn square. Dear students, each and every term is the 4n plus 6 is there. My dear students, this is 2s into 4n plus 6. This is what? C0 square, C1 square, C2 square, and so on, Cn square. My dear students, the 2s equal to 4n plus 6. Just now we completed. That is a very important formula. C0 square, C1 square, C2 square, and so on. Cn square is the students 2n Cn. My dear students, what is that one? 2n Cn. So this is 2n Cn. So divided by 2 on both sides. This is undoubtedly S equal to 2n plus 3 into 2n Cn. What is the students? S equal to 2n plus 3 into 2n Cn. Okay students? 2n plus 3 into 2n Cn. This is the proof. Okay students? My dear students, C0, C1 square, C2 square, minus C3 square, and so on, minus 1 power n Cn square. N is even, n Cn by 2 into minus 1 whole power n by 2, n is odd 0. So students, first we can write the expansion 1 plus x whole power n, C0, C1x, C2x square, C3x cube, and so on, Cn x power n. This is the 1 plus x whole power n. Now students, x minus 1 whole power n. What is the students? C0 x power n. Okay students, how to write this is C0 n minus 0 x power n. After then minus C1 x power n minus 1. Okay students, C1 x power n minus 1 into minus 1. After that students, C2 x power n minus 2 minus 1 whole square is the plus. So there similarly C3 x power n minus 3 minus 1 whole cube is the minus, and so on students. How can you write the students? Cn minus 1 power n. Okay students, Cn minus 1 power n, x power 0 is the 1. So students, so what we observe students, C0 square, when you can multiplication, this is the C0 square, this is minus C1 square, this is the plus C2 square. So students, we observe the coefficient of x power n, this will be taken, yes, this is 1, this is 2. Okay students, now we are taking 1 into 2. So how to write the student? Coefficient of x power n in the right hand side of 1 into 2. So the coefficient of x power n in the right hand side of 1 into 2, that is what? C0 square. After that students, minus C1 square. So these are cancelled, C2 square. After then minus C3 square, and so on students, minus 1 power n Cn square. Is it clear students? Minus 1 power n Cn square. Now students, we have to find the coefficient of x power n in this left hand side of in 1 into 2. Okay students, so dear students, the coefficient of x power n in the left hand side of the 1 into 2. So dear students, what is it there? A plus b into a minus b, a square minus b square. So a square minus b square. Undoubtedly students, this is whole power n. Okay students, my dear students, we observe undoubtedly we are getting, my dear students, when we are observing here clearly, what is there? We are taking x power n coefficient. My dear students, x power n coefficient. That means how to find the x power n coefficient here. This is the students, when we are taking undoubtedly students, always we got here 2 is there. So when we are taking the x power n coefficient, undoubtedly here students, the must be the x power n coefficient undoubtedly is the coefficient of x power n is the students, when we are taking NC n by 2. My dear students, NC n by 2. The NC n by 2 is the students x square, undoubtedly students, x square whole power, what is the student, x square whole power, n minus n by 2 is the n by 2 minus whole power n by 2. Is it clear students? How can we write? The TR plus 1 is the NCR x power n minus r y power r. Similarly, the NC n by 2 is the x square n minus n by 2. N minus n by 2 is the n by 2 minus 1 whole power n by 2 by using general term. TR plus 1 is NCR x power n minus r y power r. So students, here 2 cancel. 2 cancel. Now this is what students, the coefficient of x power n is 2 cancel, that is minus 1 whole power n by 2 NC n by 2. This is defined for only n is even. Clearly, NC n by 2. N is even. Undoubtedly students, n is even 0 by 2, 2 by 2, 4 by 2. It is defined. For n is odd, it is not defined. So undoubtedly the coefficient of x power n in the 1 into 2 left hand side is 0 for n is odd. This is possible for n is even. What is the students? This is possible for n is even. If n is even, this one. For n is odd, this is f. If n is odd, even. If n is odd, undoubtedly the coefficient of x power n is 0. Okay students? Is it clear? My dear students, is it clear students? N is even, undoubtedly the suffix will be the integer. N is odd, 3 by 2, 1 by 2, that is undefined. So the coefficient of x power n is clearly, for n odd, it will be 0. Okay. My dear students, find the value of 20C1 upon 20C0, 20C2 upon 20C1, 20C3 upon 20C2. Undoubtedly students, the 20 into 20C20 upon 20C19. Find the value. So my dear students, so NCR, everybody know that the NCR upon NCR minus 1. What is the students? NCR upon NCR minus 1. This is the students R n minus r plus 1. So upon r n minus r plus 1. So we can written as n minus r plus 1 upon r. So students, 1 and 0 successive, 2 and 1, 3 and 2. So 20 and 29 are success. Therefore students, 20 minus 0, 20 by 1. This is a 2 into, dear students, undoubtedly 20 minus 1 is the 19, suffix is there 2. After that, students, is there 3. So 20 minus 2, n minus r plus 1, 20 minus 2 is the 18, suffix is there 3. Similarly, students, is there 20 into, what is the formula, students? 20 minus 19, 1, suffix is there 20. So students, this is what? 20 plus 19 plus 18 and so on, 1 to 1. This is the formula of n into n plus 1 by 2. What is the, students? N into n plus 1. N into n plus 1 by 2. Where n is the, students? 20. N is the, students? 20. Therefore, 20 into 20 plus 1, 21 by 2. This is the solution 210. What is the, students? 210. Write down. Dear students, n is a positive integer. N is a positive integer and CR is the NCR. CR is the NCR. Then find the value of sigma r equal to 1 to n r square CR by CR minus 1. R square CR by CR minus 1. Okay, students, my dear students, we can written as this is what? Sigma r equal to 1 to n, r square is there. This is we can written as NCR upon NCR minus 1. So dear students, the sigma r equal to 1 to n r square. So dear students, how can you write this is the, students? This is undoubtedly, my dear students, how can you write this is? The suffix r is there. Here the n minus r plus 1 suffix r. How to write? N minus r plus 1 suffix r. So students, sigma r equal to 1 to n, r cancel. This is n minus r plus 1. Dear students, undoubtedly this can be written as the, students, sigma r equal to 1 to n, r equal to 1 to n, my dear students, n plus 1, what is the, students? N plus 1 into r minus sigma r equal to 1 to n, r into r is the, students, r square. So students, n plus 1 into sigma r equal to 1 to n r minus sigma r equal to 1 to n r square. Sigma r is the, students, n into n plus 1 by 2. This is n plus 1 into, this is n into n plus 1 by 2. Sigma r is the, students, n into n plus 1 by 2. This is r square is the, students, sigma r square, we know that n into n plus 1 into 2n plus 1 by 6. Sigma r square is the, students, n into n plus 1 into 2n plus 1 by 6. So students, this is n into n plus 1 by 2. Is there n plus 1? So dear students, this is what? 2n plus 1 by 6. Is it clear, students? How can you write the, student? This is n into n plus 1 by 2. Is that common? Is there n plus 1? So the 2n plus 1 by 6. My dear students, this is we can written as n into n plus 1 by 2. This is the students 6n plus 6 minus 2n minus 1 by 6. So what is the students? How can you write? This is undoubtedly students. We got this one. My dear students, here n into n plus 1 by 2 taken the common is there students 3. So students, undoubtedly it will be 3 into n, 3n plus 3. What is the students? 3n plus 3. So students, the n into n plus 1 by 2. 3n minus 2n is the n. 3 minus 1 is the 2 by 6. Is it clear student? 3n minus 2n is the n. 3 minus 1 is the 2. So students, we got n into, how to write this is completely n into n plus 1 into n plus 2. n into n plus 1 into n plus 2 by 2, 6 is 12. What is the students? n into n plus 1 into n plus 2 by 12. Okay students. My dear students, what is the LCM is there here? 3. This is also 3. So students, small mistake is these students here. We are taking the 3 jar is 6. Therefore LCM 3, 2 3 jar is the 6. n into n plus 1 into n plus 2 by 6 is the answer. Okay students. Just we taken the common is there. Only 2. That's why 2 3 is 6. Okay students. My dear students, this is today's students. Okay student, tomorrow we will discuss about the binomial, okay student, expansion for the rational index. Okay students, the binomial expansion for the rational index. Okay, thank you all.